Welcome back to Algebra 2, Semester 2. This is Chapter 6, Section 2 from the Big Ideas Math textbook. And our question today is, what is the natural base E? So we're going to start straight off with the core concept here about what E is. E is irrational, like pi. You know pi, 3.14159, that number? Well, that was found when uh, the mathematicians were looking to see the relationship between circumference of a circle and diameter of a circle. And just like we were talking about in the last lesson with compound interest, mathematicians were looking at this relationship with compound interest, and they realized that when they increased the number of compounds, um, that what they were getting started to approach the same number every time. So as you can see here, it says as x approaches positive infinity, the quantity of 1 plus 1 divided by x to the x approaches e. And e is basically 2.7182. That's what I remember to plug in my calculator if it doesn't have the e button. And it is simply a natural base. Okay, so we're thinking about this as compound interest, and we're compounding so many times that we reach this number. All right, it says simplify each expression. The nice thing is that e is just considered a base, just like we would consider any variable like x or y, how we were doing this in chapter 5. So if you have e to the third power times e to the sixth power, you simply add the powers. Let's see if I can get a pen. There we go. You add the powers and you're done. So it's e to the ninth, and my pen's not working, but you know it's e to the ninth. And then we have 16 over 4. So 16 over 4 is just 4, and e to the fifth over e to the fourth is e to the 5 minus 4 on top. I'm just going to do it with my finger and see how it goes. It's a short lesson anyway. Okay, and so that is just 4e. Over here, that 2 distributes to both of the powers. So you've got 9e to the negative 8x. And we're going to take that down and say it is 9 over e to the 8x. Okay, so e to the 7th times e to the 4th. 7 plus 4 is 11. 24 over 8 is 3. And 8 minus 5 is also 3, so I have 3e to the third. This is 10 cubed e to the negative 9x. So you've got lots of business going on here. First you have the 10 cubed, so that's 1000. And then the e to the negative 9x goes down and becomes positive. Okay, so you just remember those rules from chapter 5, and we can rock and roll with simplifying. Okay, here's your graphs. The function of the form y equals a, so that's your initial amount, times e, that's your base, to the rx, where remember r is your rate, but it needs to be a decimal, and x is time. It's called a natural base function. And the a value, the initial amount, is always positive and not 0. And then the rate can either be positive, meaning growth, or negative, meaning decay. And then this is just the image of the graphs to give you an idea. But we're going to go ahead and use our calculators. Okay, it says tell whether the function's growth or decay. Take a look. Excuse me. You want to be looking up here. That is just an x. So this is growth. This is a negative 5, or negative 0.5x. So that is decay. Again, just look at those exponents. I promise it's that easy. It's a positive x, so you have growth. It's a negative x, that's decay. This is a positive 2, so that is growth. Okay, now, so we were talking about how E comes from when you're compounding bigger and bigger, you're compounding more often. So basically you're not even going to use the compound interest formula anymore from last lesson. You're just going to use the number E instead. So the amount A is equal to the principal amount times the natural base E raised to the rate as a decimal times the time. And we just say PERT. It's the PERT formula, the compound, the continuously compound interest formula. All right, you and your friend have accounts that earn annual interest compounded continuously. The balance A in dollars of your account after 2 years is modeled by A equals 4,500 times E to the 0.04 t. So yours is that equation. That means ours is that equation. The graph, however, is the balance of your friend's account over time. And they want to know which account has a greater principal. So remember what principal is. Principal is just that initial amount. So our account, or your account, is 4,500. So we get to start right here. It says, which account has a greater principal? Well, we can already see if that's where we start. We do. So ours is greater. Then it says, which has a greater balance after 10 years? All right, how do we find a balance after 10 years? What do we need to do? We need to grab our calculator and plug it in. Now, if you're wondering about E, there is a button on our calculators. It's awesome. You have to press the second key first, and it should be the division key. So we're going to type that in with a 10 for the T. So in my calculator, I have 4,500 times, I press the second button, and then I press the divide button because that's going to give me the E. Then I need the caret key, and I do 0.04, the times button, and 10. And I got 6,713 and 21 cents. Okay, so after year 10, 6,700 here somewhere. I don't know. Okay, so we can see that at some point, even though we started with more money than our friend must have a greater interest rate than us because they end up with more money over time. So ours is a greater, I needed the word principal, and then the friend is a greater balance. Okay, if you're having problems with your calculator, make sure you ask. Alright, here's our last problem. You deposit $4,250 in an account that earns 5% annual interest compounding continuously. Okay, we want to know what is the amount over time. So the amount over time is equal to PERT, P times e to the RT. So you plug in your principal, you have your E, you have your rate, which is 0.05, and you have your time. And that is our amount over time. Okay, I hope you're having a good day.